Unit 3, imaginary and complex numbers. Lesson 3.1 is simplifying radicals with negative radicands. So I'm sure you're thinking, imaginary numbers, what the heck is that? They're not as hard as you would think. Imaginary numbers are going to happen when we try to square root a negative number. And so that's actually the definition. The imaginary unit, it's going to be, the letter I, is defined as the square root of -1. A pure imaginary number is written in the form bi, where b is the real number, I is the imaginary part. So it's like having a coefficient or a number in front of I. Just like when we have 2x or 5x, it's 3i, 4i, 2i, -I, all that kind of stuff. So we need to be able to simplify negative square roots. This is going to be very similar to what we just did. So if I asked you what two numbers would multiply together, and they have to be the same numbers, to make -121. Well, you might say -11 times -11, but that would equal +121. And we obviously can't have 11 times 11, that would be +121. This is not possible, and hence the imaginary number part. So what we need to do is we need to rewrite this as the square root of -1 times the square root of 121. I'll keep it together since this is a perfect square. And then the square root of 121 is 11. And then we just said that the square root of -1 is I. And that's it. 11i. All right, number 2 is even easier. So again, I cannot square root a negative number. So just think about square rooting 3. 3 is not a perfect square. But I'll go ahead and separate them again. I'll have square root of -1 times square root of 3. This I can square root. That is I. So it would get brought out in front and have I square root of 3. And that's it. Number 4, square root of -20. We know 20 is not a perfect square, but it has a perfect square of 4 in it, times 5. Well, that makes +20, so we're going to have to multiply this by square root of -1 to actually make this equal -20. Okay, so then this would be 2. The square root of -1 is I. We put it after the 2, and then square root of 5. 2i square root of 5. Number 5, -192. What I'll get to where I do is I just put the square root with the perfect square, and I just know that when I square root it, it's an I, so it's an option 2. 192, let's look here, could be divisible by, I don't think 64, oh, yep, 64 and 3. So the square root of 64 is 8. Since it's negative, it would be 8i square root of 3. Okay, so again, square roots cannot be negative. There's no number times itself that ends up being a negative. Talking about cube roots can be negative because you're taking a number times itself 3 times, an odd number of times. We're going to always make the negative be with the perfect cube. So -125 is already a number on our list. I know that the cube root of that is 5. Well, since it's negative, it must equal -5. And let's check that. So I should be able to say that -5 to the 3rd power equals -125. So let's check. -5 times -5 times another -5. This would make 25. Positive, right? And then times another negative would make -125. So again, cube roots can be negative, square roots cannot. All right, number 8, cube root of -135. I'm guessing there is a 27 hope in that. Yep. Okay, so I'm going to make the negative go with the perfect cube, 27. I don't know why that looks so blurry. And then times the cube root of 5. So the cube root of -27 would be -3 cube roots of 5. Because -3 times -3 is 9. 9 times -3 makes -27. And then number 10, I'll let you pause and try that one. Okay, you should have taken out a cube root of negative 27. That would become negative 3 on the outside, cube root of 6 left over. And the only thing that's different about 11 is having this negative 2 times whatever the cube root of negative 250 simplifies to make. And so I know there is a perfect cube of negative 125 times the cube root of 2. And the cube root of negative 125 is negative 5. And so this negative 2 times negative 5 is 10 cube roots of 2. So it became positive on the outside because that times negative 2 was in front.